Hello everyone. In this video, we are going to take a look at the factor label methods of converting units. Okay, so the main goal here is to take a quantity in some unit and then convert it to another unit. But here's the kicker. We're not just going from, let's say, I don't know, 100 milliliters to 0.100 liters. What we're looking at is maybe something like, I don't know, a kilometer per hour and converting that to a meter per second, which is actually going to be our first example. Okay. And what the difference is here is that the first one is just going from one unit to a bigger unit, or smaller to a bigger, or bigger to smaller, whatever the case may be. Where now what we have is we have a combination of units, like a kilometer an hour, or liter per second, or I don't know, kilogram per minute, or something like that, and converting it to something else. All right, now in terms of the conversions, what has to hold true is, like in this case, you have a length unit, which is kilometer, going to a length unit, which is a meter, and then a time unit, which is hour, going from a time unit, which is a second. So like the units have to jive and make sense, but this is what we need to figure out. So there's ultimately 3 steps we need to do. The first step here is we have to identify which units need to be converted. So that's step number 1. Which units need to be converted? Number 2, we have something called conversion factors, which we'll talk about. And 3, we're going to have to do some canceling units, okay? And then solving some math. And again, you're going to need your calculators out for this. So please, as you go through this lesson, have that calculator out. All right, so let's just get started and again, kind of follow along, and hopefully it makes some sense after a couple examples. I will tell you the honest truth. The first time you're going to see this, you're like, what are you talking about? You just got to keep working through it and keep watching the videos and just keep thinking about what I'm saying here, okay? So the first one is 100. Now I'm going to leave it as 100 decimal, and the reason why the decimal's there is this tells us it's 3 significant figures. So it's 100. Now the way I'm going to write the unit is it's a kilometer per hour. I'm actually going to write it as a fraction like that. All right, we're not going to write it with the slash, we'll write it as an actual fraction. And what we want to do is we want to get 100 kilometers per hour. And the reason why I start with this one is because this is a common speed that maybe when you start to drive, you're going to drive on the highway with 100 kilometers per hour. Now, obviously not city roads, but on the highway, yes. And we want to figure out how to put that in a meter per second. A meter per second. That's the big question there, a meter per second. So here's what we're going to have to do, okay? We're going to look at this and we're going to kind of talk, okay, what goes with what? So the very first thing is you see you have a kilometer and you have a meter. So I think we can all agree that kilometers and meters, they go hand in hand. They're both distance units. A kilometer is bigger than a meter. I think that makes sense, right? You need a lot more meters to fit into a kilometer. And then the second unit you're going to see is that of hours and seconds, and they also go hand in hand. And again, I think we can agree that, well, there's a lot more seconds in an hour, so the hour is the bigger unit. So let's kind of match these up. And notice I tried to do a couple different colors here just so you can visualize what I'm saying. So we're going to write out some what are called conversion factors. So step 1, we've identified what units needed to be converted. We have to convert kilometers to meters and hours to seconds. So step 1 is done. Step 2 is now we have to come up with what are called these conversion factors. And you're like, what's a conversion factor? So this is how a conversion factor works. You have to think about how many meters are and kilometers, or what the connection is, I should say, between meters and kilometers. I.e., if I have 1 kilometer, because I said that's the bigger unit, how many meters are in 1 kilometer? And hopefully you remember kilo is 1,000. So in 1 kilometer, you have 1,000 meters. So that's actually our very first conversion factor we're going to have to play with. And in 1 kilometer, you have 1,000 meters. Because like I said, kilometer is the bigger unit, so you have 1,000 meters in the kilometer. The second units, you have to play with our hours and seconds. So we know that the hour is bigger, so I know it's going to be 1 hour. Now you have to think to yourself, how many seconds are in 1 hour? Well, it's not as direct as meters to kilometers because that's the metric system. That's the beauty of the metric system. So you have to think a little bit, okay? In 1 hour, you have 60 minutes, but then in 1 minute, you have 60 seconds. So you actually have to multiply those together. And since you have 60 minutes in an hour, 60 seconds in a minute, it's 60 times 60, or 3,600 seconds. That's my second conversion factor. So first you identify your conversion factors, okay, that we need to deal with. Now what we do is we're going to use those conversion factors and throw them inside this equation. So here's how this is going to work. Okay, now that we have conversion factors, now let's see how we can enter them in. Hear me out. Okay, and again, just bear with me. The first time you're going to go through this, you're going to think I have 13 heads. Okay, just please bear with me. Here's how the easiest way to think of it. Okay, I need to convert kilometers to meters. Notice in my final unit, the meter is on the numerator there. So when I put my first conversion factor in, which is my distance conversion factor, I need meters on the top because meters is on the top of my final unit. So what that conversion factor would be is it would be 1,000 meters over 1 kilometer, And again, the reason why I'm doing that is because I need meters on the top. And since there's 1,000 meters in 1 kilometer, this is how I need to write it. So let's use the same idea for time, okay? Well, take a look at my unit. I need seconds on the bottom, so I know seconds needs to be on the denominator there. So therefore, hours has to be up top. So it's 1 hour over 3,600 seconds. 1 hour over 3,600 seconds. Okay, so we've actually done step 2. We've inserted our conversion factors. So now what we do is we take a look at this and think, if this is one solid fraction or mathematical statement, in mathematics, we can cancel out or divide stuff. That's common on the top and bottom of a fraction. So what do I mean by that? Well, we can further build and say this. Okay, we can say that, look, there are some common things on the top and bottom, i.e., see how there's a kilometer on the top here and a kilometer on the bottom? Units are just like numbers. We can just cancel them out. Likewise, hours on the bottom and hours on the top, those divide out as well. And if you identify what unit you have a meter divided by a second. So that makes sense. That's what we want, meters over seconds. Take a look. Our unit was meter over seconds. So that makes me happy. Yay, I did it. Okay, thumbs up for you. I don't know how to draw a thumbs up, but if I could, I would. Okay, so we've canceled out the units and we have established that we have a meter per second. Yay for you. So now we work through the math. And again, if this is just a big math problem, the mathematics would be 100 multiplied by 1,000 divided by 3,600. And if you get your old number box out, we can work through that. And I think it's like 27.7, but I'll just plug it in my calculator. So 100 times 1,000 divided by 3,600. And sure enough, it's 27.7 repeating, so 27.8. I'm going to go 3 sig figs because 3 sig figs was in the 100. So 27.8 meters per second. So here's what this means, okay? If and when you're in your car driving 100 kilometers per hour, what you actually are doing is you're traveling about 30 meters every single second. I know I rounded, but 27.8 meters per second. So what does 27.8 look like? Well, think about the track around our football field. It's about 1/3 of one of those straightaways in 1 second, okay? So traveling 100 kilometers per hour is actually very, very quick. And sometimes it's nice to write it like this because I think that if I tell you 100 kilometers per hour, that's tough to visualize. But if I tell you 30 meters, I know I'm approximating, but 30 meters a second, that's a little bit easier to visualize because 30 meters is about the straightaway of the track, right? Or a third of the straightaway of the track. Okay, so imagine running, basically this person could run a 100-meter dash in about 3.3 seconds. Okay, so very, very, very quick. Okay, so that's very fast. So let's kind of keep working here and let's do another example. And the next example is this. It's 516 liters per second. And we want to convert that to milliliters per minute. So the first thing I'll do is I'll write out my original thing, my original number. It's 516, again, 3 sig figs. 3 sig figs because 516 are all significant figures. So liters per second. So let's figure out some conversion factors. Again, I'll color them so we know. I'll do liters and milliliters. So we want liters to milliliters, liters to milliliters. So let's do that first one. I know liters is the bigger value. So in 1 liter, you have 1,000 milliliters, okay? Here is a good illustration. Some of you maybe have those Gatorade bottles, right? You know, they kind of look like this. They kind of go in a little bit. That's, you know what I mean, right? And they have that little orange top here. I'll draw a nice little Gatorade bottle for us all, right? So you can all kind of see what I'm saying. The Gatorade bottle, okay? So in one, that's actually pretty good Gatorade. Anyways, in one of those Gatorade bottles, it's equal to 1 liter, but 1 liter is also 1,000 milliliters. So that's our first conversion factor. 1 liter is 1,000 milliliters. Again, you'll see how we enter it in a minute. The second conversion factor is now dealing with time. And for time, now we're dealing with seconds to minutes. Seconds to minutes. So again, which is the bigger unit? The bigger unit is minutes. So in 1 minute, you are going to have 60 seconds. In 1 minute, you have 60 seconds. I think we know that. Hopefully everyone remembers that. So now we enter in our conversion factors like we did in the previous. Okay, so we're going to multiply it by what? Well, what unit do we need up top? We need mils on top, milliliters on top. So the conversion factor here, it's either 1,000 milliliters over 1 liter, or 1 liter over 1,000 mils. And again, we want the mils on top. So we want 1,000 milliliters divided by 1 liter. And again, you're going to notice something right off the bat. See those 2 liters? See how they're opposite? Those are going to cancel, which is good. They need to cancel, and we'll get to that in a second. But that's how I know I'm on the right track. Now for the denominator, I need minutes on the denominator. So I'll write it as 60 seconds divided by 1 minute. And again, reason being is I need to make sure that I have my minutes on the denominator. So let's just cross-reference everything to make sure it all jives, right? Your liters are gone, your seconds are gone, and sure enough, you're left with milliliters per minute. So you can give yourself a little smiley face there because yeah, we nailed it. We got milliliters per minute in terms of our unit, which is the unit that we need. So now we work out the math. The math literally is just the multiplication across. It's 516 because that's on the numerator of the first fraction, times 1,000 because that's on the numerator of the second fraction, times 60 because that's on the numerator of the third fraction, and it's all just divided by 1. So anything divided by 1 is itself. So again, use your old number box. Again, we're going to have to only use 3 sig figs. So 516 times 1,000 times 60. And I'm getting 30,960,000. So 30,960,000 milliliters per minute. We have to be a little careful here because right now that's showing 4 sig figs. I can't have 4, okay? I can only have 3. So how I have to round is I'm going to bring, well, that 6 has to round the 9 up. That 9 goes to a 1. So we're going to have to write it in scientific notation. So it's going to be 3.10 to give us our 3 sig figs times 10 to the 1, 2, 3, 4, 5, 6, 7 milliliters per minute. Okay, so 3.10. Again, why the 10? Because the 6 rounds the 9. Whoops. The 6 rounds the 9. And then the 9 rounds to the 1. And I need the 0 in there. So basically, it'd be like 31 million. Okay, and then 31 million rounds to 3.1 times 10 to the 7. Hopefully that makes sense and you can follow what I wrote there. Okay, we're going to do one more example here just to make sure we're okay with this. And now it's going the other way. So it's a meter per second to kilometer per hour. Meter per second to kilometer per hour. I think I have one more on here too, but yeah, maybe we'll do them both. We should have time. So again, we start with our original 67.3 meters per second. And we're going to enter in some conversion factors. So we've already done these, meters and kilometers. So in 1 kilometer, you have 1,000 meters. And in 1 hour, you have 3,600 seconds. Why was it 3,600 seconds again? Hopefully you all remember. It's 60 minutes in an hour times 60 seconds in a minute. So we throw our conversions in there. Again, identify, you want kilometers on the numerator of my final fraction. So I have 1 kilometer over 1,000 meters. And you need hours in your denominator. So you have 3,600 seconds over 1 hour. All right. Again, we cross-reference everything. So meters are gone. Yay, that's good. We don't want meters. Seconds is gone. Yay, we don't want seconds. And definitely we're left with kilometer per hour. So mathematically, you can write it out, 67.3 times 1, which I don't care about, times 3,600, all divided by 1,000. Okay, so you get, oh, that popped up. So you get 67.3 times 3,600 divided by 1,000, and I'm getting a pretty big number. I'm getting 242. Now it is 0.28, but again, we only want 2 sig figs, so 242 kilometers per hour. So that's pretty darn fast, 242 kilometers per hour. Let's just do one more. Again, a little bit more interesting one here because it's dealing with a really big unit, and the big unit is years. So maybe take a minute right now by yourselves and see if you can maybe pause the video and try and chip away here. The liters and milliliters isn't that bad. It's the one with the years part, which again, you got to think a little bit, okay? So if you want to pause the video now, you can, and give it a whirl, and then come back and see how you did. But I'm just going to keep going here and solving. So for this one, 89.42 liters per hour. And again, your conversions are liters to mils, which again, we've done above. So in 1 liter, you have 1,000 milliliters. And then hours per year. So we obviously know 1 year is the bigger value. So how many hours are in a year? How would we do that? Well, we have to break up a year. What I think we know is that there's about 365 days a year. Now that's a bit of a approximation, but we'll deal with 365. It's actually 365 and a quarter, but whatever, we'll say 365. And what we know is in each day you have 24 hours. So if I do 365 times 24, this gives me 8,760 hours in 1 year. That's a lot of hours in a year, but that's how it is. So now we enter our factors again. So our first factor, we want milliliters on top. So you have 1,000 milliliters over 1 liter. And the second factor, we're on years on the bottom. So you get 8,760 hours over 1 year. Okay. Again, I cross-reference all my units. So liters are done, hours are done, which is good. Okay. We look at our final math that we have to work through. It's 89.42 times 1,000 times 8760, or 8,760. All right, our unit is going to be a milliliter per year, which is good. That's what we want. And we can just work through that math. So 89.42 times 1,000 times 8760. And I'm getting a pretty big number. I'm getting 7,833,19200. So I'll go 7,833, yeah, 19200. So what does that give us? There's my comma there, my comma there. So it's like, it's massive. 783,319,200. All right, so we have 4 sig figs we can work with. So we actually don't need scientific notation. I could just kind of round. So 783,300,000 milliliters per year, which seems ridiculous, right? But I mean, it's looking at the duration of a year, the course of a year. So that's it. So what you're going to work on now, everyone, is you're going to work on some practice. And in the next 2 pages, there are just tons of practice for you to work through. And that's what I'd love you all to work on now. Okay, so thank you so much. Good luck with this, and just work away. Okay, bye for now.